All right, so here's an application of matrices, and we talked about, a matrix being a collection of numbers in a structured way. So it's a good way to organize and arrange information. And in fact, a lot of programming languages organize in arrays and matrices, in similar formats, and they have similar addresses in terms of, the element in the one, row one, column two, and things like that. So, and in terms of spreadsheets and databases and so forth. Matrices are basically utilized in a lot of those areas. So here we have a table of information related to economics. So we have a table that shows loans by loans for startup businesses for men and women, right, over a 3-year span from 2003 to 2005. So it says write two matrices that represent the number of new businesses and loan amounts for one for women and one for men, right? So we'll start with the women matrix. So it'll be a 3x2. So because what we want is the number of new businesses and the loan amounts, right? So it's going to be 27 and then 576,000, 41. And you could put units in here if you want to. I'm just going to leave them. I'll leave the dollar amounts as just plain numbers when I put them in the matrix. But if you want to put units in there, you can. Okay, so there are. That's my women's matrix, right? In terms of businesses and loan amounts. And so I have one column that represents businesses, the other column that represents the dollar amount. Then I have rows that represent the years, right? 2003, 2004, 2005. Okay. So, all right. So next, we'll do one for men. All right. So for men, we'll use M as the label, but we could have used A and B or whatever you want, right? So 36, 32, 28 is the first column, and then the second column is 864,000, and we got 672,000, and then 562,000. All right, so those are our two matrices. So that's step A. So step B, find the sum of the numbers of new businesses and loan amounts for both men and women over the 3-year period expressed as a matrix. Okay, so there we go. So all they're asking us for is the total amount, right? So the total, which is the two matrices combined, right? So because of the properties of matrices and the properties of matrix addition and subtraction and so forth, it lends itself to figuring out a total amount, right? We'll find the total amount of businesses in 2003 and the total amount of loans that they received, right, for men and women. And the same for 2004, 2005. And so let's do that. So we'll take these matrices and add them together. All right, so I'm just going to keep this notation here, and then I'll just add them by kind of mental math or using calculators, right? So 27 plus 36 is 63. 41 plus 32, I'm going, I'll keep the same because I've been going by rows. So let's do 567,000 plus 864,000. So that's 1,431,000. And then 41 plus 32 is 73. And then we'll add 902,000 plus 672,000. So that's going to be, let's see, 1,574,000. And then last but not least, 35 plus 28 is 63. And then we will add 777,000 with 562,000. So that's going to be, let's see, 1.3 million, right? 1,339,000. All right, so that's our total matrix, right? So that's the total number of businesses and loan amounts for those 3 years. All right, so that's just one example of how you would use matrices to organize information. But you can see with any kind of information, right, whether it be statistics for sports, or maybe some medical data or pharmaceutical data, scientific data, any kind of data, right? It could be polling data for political polls. This could go a lot of different ways. So anytime you want to organize information, a matrix is a good way to do it. And in fact, the way it's done a lot of times, even if it's behind the scenes, a lot of it's done, on the back end with computers and databases and things like that. Like I said, so we don't operate with matrices a lot in the real world on a day-to-day basis, but they're going on behind the scenes more than we know for sure. All right, so as usual, let me know if you have any questions, and hopefully this all makes sense, and we'll get some practice time when we get to class. But if next we'll talk about matrix multiplication, which is a little different than scalar multiplication. That's where we multiply two matrices together, and it's a little different because the dimensions don't necessarily have to be the same. In fact, sometimes they cannot be the same, and so there is something that does have to match up, and we'll talk about that next time.